The volume of an ideal gas is V at pressure P. On increasing the pressure by delta P, the change in volume of the gas is delta V1 under isothermal conditions and delta V2 under adiabatic conditions. Under which of the two conditions will the change in volume be more? Explain. So we have ideal gas, okay, having volume V at pressure P. So on increasing the pressure by delta P, the change in volume of the gas is delta V1 under isothermal conditions. So first we consider isothermal conditions, okay. So I'm writing for isothermal condition, okay. We know for isothermal condition, temperature is constant. Now, for n equals 1, ideal gas equation, okay, is given by PV equals RT. So let's call it equation 1, and we know R is constant called universal gas constant. Now we need to write ideal gas equation given by equation 1 for isothermal condition. So for isothermal condition, okay, for isothermal, so I'm writing conditions, equation 1 can be rewritten in this form, okay, PV equals constant. Why? Because R is constant and T is constant. So we have this. So let us call it equation 2. Now, differentiating equation 2, both sides with respect to volume. We can also differentiate with respect to pressure. So we write in this way, okay, P dV by dV plus V dP by dV equals 0. And we know this, okay, gives 1. So we can write P plus V dP by dV equals 0. So on simplification, we write P dV plus V dP equals 0. So on rearranging, okay, so we get this P dV equals minus V dP. Now we can write P equals minus V dP by dV. So we have this. Now we can write P equals minus dP by dV. So I'm writing volume V in this way, okay. And we know this, okay, term, that is minus dP by dV by V, that is change in pressure by fractional change in volume. So what is dP? This is change in pressure, and dV by V, this is fractional change in volume. So we have this, okay. So we find this. So this quantity, okay, inside the bracket is bulk modulus of gas for isothermal condition. So we write K iso equals P. So we have this. Okay, we have this. Okay, so this is called bulk modulus, okay, of elasticity, or simply bulk modulus of gas. So we have this. Therefore, we can write K iso equals P. Okay, we can start directly from this equation also, instead of doing, okay, these mathematical steps. We can start directly from this equation. And now what we do is that, okay, we write this equation, okay, we write this equation according to the question, okay. We know K iso, okay. So from this equation, okay, we can see the term inside the bracket is K iso, and K iso is change in pressure, okay. So the change in pressure or the increase in pressure from question is delta P. So we have delta P, okay. So we have this, and I'm keeping negative sign also, okay, by the change in volume of the gas is delta V1 under isothermal condition. So delta V1 by the volume, okay, we can see the volume of the gas is V at pressure P. So we have this. So this equals pressure. So we have to generalize this equation, okay, in terms of the question. So we have this. So let us call it equation 3. So we have this. Now for adiabatic conditions, we know for adiabatic condition PV gamma equals constant. Let us call it equation 4. Now we differentiate, okay, we differentiate equation 4 both sides with respect to volume. We can also differentiate with respect to pressure. So we get this, okay, P dV gamma by dV plus V gamma dP by dV equals 0. So this gives me P gamma V gamma minus 1 plus V gamma dP by dV equals 0. So on simplification, we can write P gamma V power minus 1. Okay, when the base is same, then the power adds up. Okay, we know that. And dV plus V gamma dP equals 0. Okay, now P gamma V power minus 1 dV equals, I'm taking this term, okay, on right hand side, minus V gamma dP. Now what we do, this cancels out, okay. So we have gamma P by V dV equals minus dP. Okay, so we can write minus dP by dV. Okay, so this equals gamma times P by V. So minus V dP by dV equals gamma times P. Now minus dP by dV by V equals gamma times P. Now we finally get this result for adiabatic conditions. Okay, so we have this for adiabatic conditions, and this term, okay, inside the bracket represent bulk modulus. Okay, this gives bulk modulus of gas at adiabatic condition, bulk modulus of gas for adiabatic or at adiabatic condition. So K adiabatic, this is gamma times P. So we have this. So we can use this relation directly instead of doing this calculation. Now we have equation 3. Okay, so let us call it, this is equation, this is equation 4. Now we have to write equation 4. Okay, we have to write equation 4 according to the question, and we can see this equation 4 is obtained from this equation. So what we have, okay, from question, so we have this. Okay, we have change in pressure delta P. We can see we have change in pressure delta P, and under adiabatic condition, okay, the change in volume is delta V2. So we have this. Okay, we have negative sign also. The change in volume is delta V2, and we have volume of gas V at pressure P. So this equation can be rewritten in this form, okay, with reference to the question. Okay, so we have this. Okay, and this is the bulk modulus for gas at adiabatic condition. So this equals gamma times P. So we have this. So let's call it equation 5. So this is equation 5. Now what we want, okay, so I'm erasing this. Okay, now let's see. Divide 5 by 3. Okay, so we have this minus delta P by delta V2 by V. So we have this equation 5, okay? This is equation 5. And equation 3 is minus delta P by delta V1 by V. So we have this, okay? So we have this, or let us write in this way, okay? Minus delta P by delta V1 by V. So we have this. So this equals gamma P by P. So this cancels out, negative sign also cancels out, okay? Now we can write, okay, the left hand side in this way, delta P by delta V2. So this volume, okay, can be written in this way. And we have V delta P and delta V1 is at the numerator. So we get this, okay? So I'm writing in this way. So this equals gamma. Now what we find on simplification, okay, this cancels out, this cancels out. So we get this delta V1 by delta V2 equals gamma. So delta V1, okay, equals gamma times delta V2. So we get this. And we know gamma is greater than 1, okay? So from this equation, we can write, okay, or we can tell that delta V1 is greater than delta V2. Okay, we can write this form, okay? So it means that change in volume, okay, under isothermal conditions, because delta V1 represent change in volume under isothermal conditions. So what we are getting? So we are getting change in volume under isothermal conditions, okay, is greater than change in volume under adiabatic condition. So we get this result, or we can understand in this way also, okay, since gamma is greater than 1 and gamma is delta V1 by delta V2, this is greater than 1. So what we get, delta V1 is greater than delta V2. So it indicates that change in volume under isothermal condition is greater than the change in volume under adiabatic condition.